another very important expected question on the theory of equations, the multiple choice question. Let fx equal to ax square plus bx plus c, where a, b, c are belonging to the set of real numbers and a is non-zero. Suppose fx is strictly greater than 0, it is strictly positive for all x belonging to the real numbers, and let gx is also given to be as f of x plus the first derivative of fx plus the second derivative of fx. Then, which of these following options are correct? We have to check this. First, gx is strictly positive for all x belonging to the real numbers. Second, gx is strictly negative for all x belonging to the real numbers. Third, gx is 0 and having non-real roots. And fourth, gx equal to 0 has real roots. We have to check all these. Okay. Please understand this remark first. If fx is equal to ax square plus bx plus c, where a, b, c are belonging to the real numbers and where a is also non-zero, what is the condition for the real number a and the discriminant of this quadratic equation fx? If fx is strictly greater than 0 or less than 0, okay, let's talk about only if fx is strictly greater than 0 for all x belonging to the real numbers, if and only if a real number is positive and the discriminant should be negative. What is the discriminant? B square minus 4ac, right? First. Second, if f of x is negative for all x belonging to the real numbers, then this a real number is also negative and the discriminant should be negative. These are the two very important results that we are going to use in the solution. And in our question also it is given to us that this fx is ax square plus bx plus c, and for all abc belonging to the real numbers with the condition that a is non-zero, right? And it is also given to us that fx is positive, strictly positive, this given to us. That means we are going to use the first condition. And what is the condition? That for f of x to be positive, strictly positive, a is positive and discriminant is negative. Now how I am getting this result, that I am going to explain over here. Please understand. What is fx given to us? It is ax square plus bx plus c, a quadratic equation, right? Okay, let's take a common from this. So it is x square plus bx over a plus c over a, right? Right? Okay. To make the perfect square, I am going to add and subtract b square divided by 4a square so that I can get a perfect square from these three terms. So that is equal to a into, okay, that is x plus b over 2a whole square, right? Plus, taking the LCM for these two, we get 4ac minus b square divided by 4a square. And this is your f of x. This implies what? If f of x is positive, then a should be positive, right? This is already positive, fine. 4a square is also positive, but the numerator, this should also be positive. That means 4ac minus b square should be positive, or you can also write it as that b square minus 4ac should be negative, which is your discriminant. So for the condition fx to be strictly positive, a should be positive and the discriminant should be negative. And what if f of x is strictly negative? For that, what can be the condition? This, for fx to be strictly negative, a should be negative, right? First term is positive, yes. The denominator is positive, right? But to make this complete right hand side to be negative, a is negative, then this numerator should be positive, right? This numerator should be positive, then only we can get the right hand side to be completely negative, because we are saying a is negative for fx to be strictly negative, right? So 4ac minus b square positive means, again, the discriminant b square minus 4ac should be negative. So in both these cases, the discriminant should be negative, but a should be positive or negative as according to fx to be positive or negative as accordingly, right? Okay. Second remark is, if discriminant is positive, then we are having two distinct real number solutions, right? If discriminant is 0, then we are getting the repeated real number solutions. Yes. And third, if d is strictly negative, then neither of the solutions are real numbers, which means we are getting the solutions to be non-real roots, right? Okay, now let's start with the solution. Now since fx is positive for all x belonging to R, and what is f of x? It is ax square plus bx plus c, where a, b, c are real numbers and a is non-zero. For this condition, what is the condition on a? Number 1, a is positive, and secondly, the discriminant should be negative. That is, b square minus 4ac should be negative, right? Okay. Now what is gx given to us? It is f of x plus first derivative of fx plus second derivative of fx. So we have fx to be ax square plus bx plus c plus derivative of fx, first derivative of fx, that is 2ax plus b, and then again second derivative of fx, that is 2a only. So that is equal to ax square plus b plus 2a into x plus 2a plus b plus c, right? Okay. What can we say about gx? Is it positive or negative? Because we are having a to be positive and the discriminant is negative for fx to be positive. So we are going to use these two conditions for gx. So for gx, what is we are having? A positive and the discriminant of fx, that is b square minus 4ac to be negative. We are going to use these two conditions for gx. Alright, let's find the discriminant of this gx now. We have for gx a positive and the discriminant of gx, that is equal to b plus 2a whole square minus 4 times a into 2a plus b plus c, right? So it is b plus 2a whole square minus 4 times a into 2a plus b plus c, right? So this is equal to, just opening the bracket, it is b square plus 4a square plus 4ab minus, it is 8a square plus 4ab plus 4ac, right? So that is equal to, this 4ab cancelled out with this 4ab, and this 4a square minus 8a square becomes negative of 4a square. So it is b square minus 4a square and minus of 4ac, right? So this is equal to b square minus 4ac minus 4a square, collecting these two. For fx, b square minus 4ac is negative, right? So it is negative and 4a square is positive. So this complete discriminant is negative, right? So for gx, we are having a positive and discriminant of gx is negative, which means, okay, let me write first. For gx, we are having a to be positive and discriminant of gx is negative. And the condition for gx for these two conditions is that gx is, yes, positive, right? So this implies gx is positive for all x belonging to the real numbers. And secondly, we are getting the discriminant of gx also to be negative, which means negative discriminant means gx is having non-real roots. So option A is correct and option C is also correct. Thank you.